children, welcome to maths classes. Children, today let's discuss the topic real numbers and their decimal expansions in the chapter Number Systems of Class 9 NCERT textbook. Children, do you know what are real numbers, children? Yes, children, you are aware, I know that. Real numbers are nothing but rational and irrational numbers. Both rational and irrational numbers together are called as real numbers. Children, you know rational numbers will be in the form of P by Q, where Q not equal to 0. And irrational numbers will not be in the form of P by Q, where Q not equal to 0. So you know this, children, what are rational and what are irrational numbers. There is another way, children, to know which are rational numbers and which are irrational numbers. Based on the decimal expansions of the real numbers, you can check whether the numbers are rational or irrational. That is, based on the decimal expansions of the numbers, of the real numbers, you can tell whether that number, that real number is a rational number or irrational number. Let us now see how you can tell the numbers are rational or irrational based on the decimal expansions. This is example 5 in your textbook, children. Find decimal expansions of 10 by 3, 7 by 8, 1 by 7. Children, these three 10 by 3, 7 by 8, 1 by 7. These three numbers are in the form of P by Q, where Q not equal to 0. That means these three numbers are rational numbers. But let us check the decimal expansions of these numbers and we will see how the decimal expansions of rational numbers will be there in this problem, children. Let's find decimal expansions of each and every rational number here. 10 by 3. First is 10 by 3. Let's do division. 10 by 3. 3 3s 9. 10 minus 9 is 1. You keep decimal point. You get 3 3s 9 again. 1. Again 0. 3 3s 9. 1. So again 0. 3 3s 9. 1. See, children, if you see here, this continues. Again you will write 3 3 is 9, 0, 10 minus 9 is 1. Like this it continues. So, what decimal expansion you got for 10 by 3? 3.3333 and so on. See, children, here the number 3 is repeating. After decimal, 3 is repeating. So, this number, this decimal expansion can be written as 3.3 bar. Bar on 3. After decimal point, the digit 3 is repeating, children. Which digit is repeating? 3 is repeating. So, instead of writing 3 continuously many times, you write bar on digit which is repeating. Here 3 is repeating, so you write 3 bar. So, 3.33 and so on can be written as 3.3 bar. So, the decimal expansion of 10 by 3 you got as 3.3 bar, children. Let's see the second one. 7 by 8. Okay, children, 7 by 8. Let's see what you will get for this. 8, 7. You will not get 8 ones 8. You will not get, so you will write 0 point. Then you will get what? 70 next. 8 7s are 56. 8 8s are 64. 10 minus 4 is 6. You get 60. 8 7s are 56. You get 10 minus 6 as 4, 40. 8 5s are 40. Remainder is 0. Here what did you get remainder, children? Remainder in this 10 by 3 you got remainder as 10, 9, 1. 3 3s are 9. 10 minus 9 is 1. Again 3 3s are 9, 1. Remainder is not becoming anywhere 0 here, children. If you observe here, remainder becomes 0. In 7 by 8, we got remainder as 0. 7 by 8, what is the decimal expansion? 0.875. So, Observe this decimal expansion here, children. This expansion is ending at some point. That means if you observe here 10 by 3, 3.3333. It is not ending. It is not terminating. What is another word for ending, children? Terminating, right? This is non-terminating decimal, children. If you observe this, this is non-terminating decimal expansion. The decimal expansion is continuing. It is not ending. It is non-terminating. And what is happening to this digit after 3? This 3 is getting repeated. That means non-terminating, recurring. It is recurring. It is repeating. So when you divided 10 by 3, you got non-terminating, recurring decimal expansion. And here what did you get, children? Here the decimal expansion got terminated. These decimal numbers, it got terminated. So decimal expansion, what you got here is terminating decimal expansion. Terminating. So till now, when you did 10 by 3 and 7 by 8, you observed that decimal expansion in one case. Case 1 is non-terminating and recurring. Non-terminating, recurring decimal expansion. And in 7 by 8, case 2, you observe that decimal expansion is terminating. That is, the decimal expansion is ending at that point. Let's see another example. 3. 1 by 7. Dividing 1 by 7 is not possible. So 0 point, you get what? 10. So 7 ones are 7, 3. Again you get 0, 7 fours are 28, you got 10 minus 8 is 2, 20, what 7, 2s are 14, 6, it is not possible, 60, 7 sevens are 49, 7 8s are 56, you got 4 again, 0, then 7 5s 35, I am writing here, children. 10 minus 5 is 5. Again you get 0. Next what you will get, children? 7 sevens are 49. Now again 10 minus 9 is 1. 0. You get after 7, 7 ones are 7. 10 minus 7 is 3. Again 0. 7 fours are 28. 10 minus 8 is 2. 0 again. 7 twos are 14, 10 minus 4 is 6, 0 again, 7 8s are 56, 10 minus 6 is 4, I am writing here again, 4 as reminder, 0, 7 5s are 35, 10 minus 5 is what, children? 5, 0, 7 sevens are 49, again 1. 0. Again what you will get? 7 ones are 7. 3. If you observe, children, in this decimal expansion, if you see 0.142857. Again 142857. If we are continuing, remainder is never becoming 0 here. Again the decimal expansion is continuing 14287. So the digits 14287 are repeating in this. Yes, in this decimal expansion, these 6 digits 142857 are repeating. If you observe here, only one digit 3 is repeating. 3, 3, 3 and so on. So we wrote 3.3 bar. Here 142857. These 6 digits are repeating. So you write 0.142857 bar. Why, children? These 6 digits are repeating here. So you write bar on these 6 digits. And you also observe that what is happening here? It is non-terminating and what? Some part of the decimal expansion is repeating. So in this case also you got what? Non-terminating, recurring. Recurring means repeating. You got non-terminating and recurring decimal expansion. So in the first case you got non-terminating. recurring decimal expansion. In the third case also you got non-terminating recurring decimal expansion. In the second case you got terminating decimal expansion. So you already know that these are rational numbers. That means children, if the decimal expansion is either terminating, if decimal expansion is either terminating or it is non-terminating and recurring. If the decimal expansion is either terminating or non-terminating and recurring, then such a decimal expansion, such a number with such decimal expansion is called as rational number. So children, in this example you learned that when 10 is divided by 3, 7 is divided by 8, 1 is divided by 7. In one case you got terminating decimal expansion and in another case you got non-terminating recurring decimal expansion. So any number whose decimal expansion is either terminating or non-terminating recurring, such numbers are called as rational numbers. So children, you can tell that a number whose decimal expansion is either terminating or non-terminating recurring. You should also remember this children. It is non-terminating. See, it is 3.3333 and so on here. That means it is repeating 3.3 bar. Here also 142857 is repeating. So non-terminating recurring. If decimal expansion is either terminating or non-terminating recurring, such number is called as a rational number. And what is the opposite children? Terminating opposite is non-terminating, recurring opposite is non-recurring. So numbers whose decimal expansions are non-terminating and non-recurring are called as irrational numbers. For irrational numbers, decimal expansions will be non-terminating children, and also it will be non-terminating and decimal expansion will also not reoccur. That means here 3, 3. It is repeating, right? For irrational number, the decimal expansion will not reoccur, children. It is non-recurring and non-terminating. Then they are called as irrational numbers. So you observed that real numbers are of two types, rational and irrational. For rational numbers, if you check the decimal expansion will be either terminating or non-terminating recurring. If for irrational numbers, decimal expansion will be non-terminating and non-recurring. Children, so while solving 7 by 8, 10 by 3 and 1 by 7, we found that remainder becomes 0 in some cases and remainder does not become 0. That is, remainder never becomes 0 in certain cases. When 7 by 8 is computed, remainder becomes 0 and we got the decimal expansion. That is, we got the quotient as 0.875. Here the quotient is terminating. So, when remainder becomes 0, the quotient terminates, the quotient ends. And when remainder does not become 0, there are two cases, children. That means here only one digit gets repeated. That is, in the decimal expansion, only one digit got repeated, and here a block of digits 0.14285, these and 7, 6 digits. That means a block of digits are getting repeated. So when When it is a rational number, either remainder becomes 0 or remainder never becomes 0. If remainder becomes 0, we get a terminating decimal expansion, and when remainder does not become 0, then we get non-terminating recurring decimal expansion. It is non-terminating here, that means that decimal expansion is not ending, the quotient is not ending, and it is repeating. Here also, children, you observe that the quotient is not ending and a block of digits are repeating. So you should remember, a number whose decimal expansion is either repeating or non-terminating recurring, such numbers are called as rational numbers. And irrational numbers are exact opposite. Here, what children? A number whose decimal expansion is non-terminating and non-recurring are called as irrational numbers. You all know some famous irrational numbers, children. Root 2 pi. Observe the expansion of root 2, children. 1.414213562373095058 and so on. See children, if you observe, the digits never repeat. Here see 142857. After 6 digits again you are getting same 142857. Here after how many digits also, if you observe the digits after decimal expansion of the decimal point, if you observe, the digits are not repeating, children. They are continuously, there is a variation in the digits. That means here the decimal expansion is not terminating and it is also not repeating, children. For pi also, if you observe, 3.1415926535897932 and so on. The digits are not repeating and also not terminating. So non-terminating, non-recurring decimal expansion, if you get, those are called as irrational numbers. These are some famous irrational numbers, children. Digits in decimal expansion of pi. For pi, the digits in decimal expansion were first computed by famous Greek genius Archimedes, children. And Aryabhatta also gave decimal expansion of pi till 4 digits, children. 3.1416. Children, using advanced computers and advanced algorithms, we are able to find 1.24 trillion decimal places, children. For which, children? Trillion decimal places for pi. Till now, using advanced technology, using advanced algorithms, we are able to find 1.24 trillion decimal places for pi, children. That is why pi is irrational number. It is non-terminating, non-recurring, children. So now you are clear about rational numbers and irrational numbers. What are terminating, what are non-terminating, what are non-terminating, non-recurring. All these are topics are covered here, children.
Thank you for watching the video. Like, comment, share and subscribe.